price for using this website. So a learner hangs a graphite-covered polystyrene ball, T, that's a very fancy word, from the ceiling with a very light non-elastic rope. The sphere carries a charge of 4.8 nanocoulomb and has a mass of 2 grams. The learners now bring a charged sphere of 3.6 microcoulomb on an isolated stand closer to T. Sphere T comes to rest in a position so that the electrostatic force of the repulsion is 62.208 newtons. Okay. So now we have 4.8. We have mass in grams. Don't really use the mass in this topic. Then we have 3.6. And then we have a force. So my question to you is, why are they saying that there's a force of repulsion between the two spheres? Why is there repulsion happening?
Mm, uh, because they are thingy, what is it called? Like it means
Sorry?
they're like similar. It means like they are similar. Like
Yes, so they have the same size. Um, then for free body diagram of T, then they pushed apart by a force of 62.208 Newton. So they actually have interacted already and now they are actually separated. So it's after the fact. So which forces are acting on T? It's hanging on a rope and it has mass in grams. Rope, mass in grams. Then it experiences a repulsion force. So which forces act on this object?
there is tension. That's all. Tension.
Yes.
Uh, FG. Wait. Oh,
Yes. And what's the last one that they're speaking about here?
would be.
The electrostatic force.
Okay.
That's the
Yes.
last one.
Yes.
So you really have to be careful with um, the different types of electrostatics questions. But in this case, it's um, the electrostatic force. So that is to say, you said we have gravity, and
Yes, sir.
then the force will push it to the side. That's why it's moving away. That's the electrostatic force. I think it's Fe. Then you don't have to draw the tension in 2D, but you just draw a tension. You have to have three marks, three forces.
Yes.
3 marks, three forces. Then scrolling down. So how would you state Newton's, or I'm actually mistaking them, but it's Coulomb's law in words.
It is the magnitude of the electric force from one exerted by one point charge to another point charge, and is directly
Yes.
proportional to the product of the magnitudes of the charge and inversely proportional to the square of the distance between them.
Yes. So that when they say it's inversely proportional, what they're talking about is an increase and a decrease. So as
Yes,
F
sir.
increases, the R decreases. As R decreases, that increases. So they have a reverse relationship. They're inversely proportional. Then using the formula, how you calculate the distance between S and T. So that would be R squared. How would you find the distance R squared?
R squared.
So you have the force, you have the two charges, you have the force, you have the two charges. Can you find the distance?
Is it not the 62,208? Oh no.
Sorry?
What about that 62,208? Like I know that's not the distance, but like what does that like help us with telling us that like it's the repulsion?
That's the force. That's the force that pushes it. It's this force shown by this arrow here. It's the repulsion force that pushes it outwards on both sides. So it pushes it that way. So that's the force. Distance is measured in meters and force is measured in newtons. So they're talking about newtons, then they're talking about force. So you have the force, you have the first charge, the second charge, then only the distance is left over. Um, that's why whenever you write your answer, you shouldn't leave your units open. That's 9 times 10 to the power of 9. I'm just going to write dots. Then you'll have Q1, Q2. You'll divide by R squared. We'll have 3,6 times 10 to the power of negative 9 for nanocoulomb. So you have to remember that for that unit, it's times 10 to the power of negative 9. That's nanocoulomb. Then you also plug in the second value. Then you can solve for R squared. Let me give myself more space here. Um, so I think the K is 9 times 10 to the power of 9, if I'm not mistaken, but it's a big number. And then you
The
just
K
plug
is
in.
yeah 9. It's 9 times 10 to the power of 9.
Yes, then you have 4,8. That's times 10 to the power of negative 9 as well, because that's the second charge. Then you can solve for your um for R squared. So K, and then you have your force. Just trying to reverse the formula here. 62.208. Um, then I think you can find the value of R squared. I'll send you this question paper. So that's good that we actually spent a lot of time on that. Um, an interesting question. Calculate the angle between Calculate the angle of the rope with the vertical.